Every time a user in Accra or Nairobi types a prompt into an AI tool, they are engaging in a silent migration of data. The response feels local, but the intelligence fueling is almost certainly hosted on a server in Virginia, Dublin, or Marseille. Africa is exporting its digital potential, sending raw data across oceans, only to buy it back as a finished service. This is the ChatGPT illusion. Africa's AI ambitions are mostly software dreams powered by infrastructure elsewhere. Serious AI relies on three pillars: servers, foundation, power, life support, and networks, nervous system. Africa, home to 20% of the global population, has less than 1% of global data center capacity. To achieve independence, Africa must control its tech infrastructure and specialized hardware. The cloud is not weightless, it houses power-hungry computers. Africa has 360 megawatts of infrastructure. McKinsey estimates Africa needs $10 to $20 billion for a 2.2 gigawatt target by 2030. Without necessary servers, cooling, and fiber, achieving digital sovereignty depends on foreign operators. Africa's limited local computing power causes tromboning, where digital traffic routes to Europe then back home. This slows AI processes, increasing wait times and costs, making real-time AI nearly impossible. Relying on foreign hyperscalers, like Amazon Web Services, Microsoft Azure, and Google Cloud creates a structural foreign exchange drain. African startups pay for critical computing power in US dollars. When the Naira or Cedi drops, the cost of hosting an AI model stays the same in dollars, doubling or tripling the operational burn rate overnight. This is a startup killer environment. If data is the fuel for AI, electricity is the air it breathes. A single AI inference query requires significantly more power than a standard internet search. In Ghana, frequent Dumza power outages disrupt tech operations. In South Africa, rolling load shedding similarly threatens uptime. When the grid fails, companies rely on expensive diesel generators, making AI operations in Africa approximately twice as expensive as in Europe or America. In tropical climates, cooling alone accounts for nearly 40% of a data center's energy bill. A legislative paradox is emerging. Nations are passing data localization laws mandating that citizen data stay within national borders. But these laws are toothless if the country physically lacks the data centers required to host that data securely. Over 40 African countries have enacted data laws. Yet most data is still stored offshore. You cannot legislate data residency if you do not have the real estate. South Africa remains the most mature market, hosting approximately 1/4 of continental data center capacity. Nigeria is seeing a massive influx of capital, with its market projected to reach 279 megawatts by 2030. Kenya is developing a geothermal-powered data center scaling toward 1 gigawatt. Ghana, despite infrastructure constraints, outperformed Nigeria and Kenya on the Fitch Digital Readiness Index in 2026, carving out a precision niche in the continental AI supply chain. African leadership should see data centers as vital infrastructure. Energy-focused policies must create renewable power grids for tech hubs. Local sovereign data clouds are essential for public data under African jurisdiction. Regional integration should enhance local internet exchanges to stop tromboning traffic to Europe. Carrier-neutral facilities will cut costs by preventing telecom monopolies. We must reframe AI sovereignty. It is not just about who writes the most clever algorithm. It is about who owns the servers, the cables, and the substations. Digital independence is a physical reality. If Africa does not own the hardware, Africa does not own the future. True sovereignty is built cable by cable and server by server. The investment must shift from the software dream to the concrete reality. Only then can we ensure that the tools of the future are not just consumed in Africa, but are truly born, housed, and powered there.